Hey, this is Miss Nichols, your backyard biologist. Today we're going to learn about Punnett squares, and I recommend that you pause the video as you need to take notes in your notebook. Punnett squares are diagnostic tools or a diagram used by biologists to determine the probability of an offspring having a particular genotype. So we're going to look at what's called a monohybrid cross. Mono means one, so we're only going to be looking at one trait. The trait is, in this case, is going to be eye color. Big B stands for brown, little b stands for blue. So we are going to be crossing two purebred parents. One is big B, homozygous dominant, and the other is purebred blue, which is homozygous recessive, little b, little b. So this is how we set up a Punnett square. We're looking at a monohybrid cross, so it has 4 boxes. We're going to put one parent up here. It doesn't matter which one goes where, but they just need to be on here. So this is one parent, and this is the other parent. Horizontal axis, and one parent goes on the vertical axis. It doesn't matter where they go because the probability will be the same. The way this works is that you always place the dominant characteristic first. So this B comes down, and then this little b comes over. So again, the capital letter always comes first. So big B, little b. Again, this comes all the way down, big B, little b, big B, little b. Over here I have the possible outcomes. So in this case, there's 4 boxes. So it's a 0 to 4 ratio. Big B to little b would be 4 to 4, or we would reduce this to 1 to 1. And again, there's no little b, so that would be 0 to 4. This would be 0%. If it asked for percent, this would be 100%, and this would be 0%. So if it asked for what percent of the offspring would be homozygous recessive, it would be 0%. Or if it asked for the ratio of homozygous recessive, it would be 0. Here's another example. Let's cross 2 heterozygous parents. Again, one parent goes on the horizontal axis, the other parent goes on the vertical axis. Remember, the dominant trait always comes first. In this case, they are both dominant. Big B, little b, big B, little b, little b, little b. So in this scenario, we're going to look at big B. So this is a 1 in 4 chance. Big B, little b, we have a 2 in 4 chance, and this is a 1 in 4 chance. So again, this can be reduced to 1 to 2 chance. So we have the percentage. So this is my ratio, and this is my percentage. So this is 25%. This is 50%, and this is 25%. Again, these should all add up to 100, just to double check your math. Again, these are the genotypic ratios. They're based on the genes or the alleles, whereas the phenotypic ratio would be, again, since these had big B's, they would be 75% brown and 25% blue. Okay, we have a puzzle. You have a brown-eyed mouse, and you want to determine if it is a heterozygous or a homozygous dominant mouse, because you look at it and it's going to have brown eyes no matter what. So what we're going to do is we're going to perform something called a test cross. And with a test cross, we always cross it with a homozygous recessive, which is our little b, little b. So here's our scenario. I've set up our test cross subject here. And so if it was heterozygous, big B, little b, we're going to see that, and I'm doing it this one down, this one across, this one down, this one across, this one down, this one across. So in this scenario, half of them, or 50%, have brown eyes, and 50% have blue eyes. Okay, so that gives us that ratio. Now let's cross it with our other possibility, which is homozygous dominant. In this case, again, big B, little b, big B, little b, big B, little b, big B, little b. In this case, we have 100% are going to have brown eyes. So simply by breeding that organism with a recessive, 100% recessive individual, we can determine what its genotype is going to be, and that is called a test cross.
Hey, this is Ms. Nichols, your backyard biologist. Take a moment and get outside.